name's Chris, and over the past number of months I've been developing the game Harrier Attack Reloaded for the Amstrad Plus machines, and it's been a real interesting project for me to work on. So about 6 years ago I decided to teach myself Z80 assembly. I've been interested in programming for a long time, since we got our first Amstrad computer back in 1987. And of course, unlike modern computers today, the Amstrad came with a manual that was just full of programs that you could type in, and it really helped you learn how the machine worked and give you a great understanding. And people used to make games, and would often, even through Amstrad Action and other computer magazines, we used to type in the type-ins into the computer and see what we could make it do. And so the Amstrad was a great programmer's machine, and although I was a young child at the time, I didn't really understand much about programming back then. I did try to make a font which I produced, and this is a printout that I saved from it. I produced a font by typing in, calculating the bytes manually on graph paper, colouring in each little pixel and working out what the corresponding bytes were, and typing them into the Amstrad in a basic program, and then running it. And this is the end of that font that I made. That was when I was about 7 or 8 years old, and I really enjoyed programming on the Amstrad. And I also made a game called Operation Desert Storm. It was just after the first Gulf War in 1991, and I thought it would be great to make a game in BASIC, so I chose that theme. But of course I didn't know enough about BASIC, I didn't know enough about programming to make it fast enough in order to make it a good game. So fast forward to about 2020 or so, I thought, what about learning Z80 assembly language? And I thought, well, I've learned Python, I've learned Make It E, I've learned all these other languages successfully. How much harder can Z80 assembly be? And once I started to get into it, it was really, really enjoyable. It's quite unlike other programming languages in that you need to write a lot in order to make the computer do anything, but it really shows you how the computer works internally, and it's really enjoyable once you make it produce something. It's really good, and of course it's the most efficient way of programming a computer, so it's really, really fast. I used to type in example programs from Amstrad Action, and sometimes they had machine code in them, and I didn't know what machine code was. I couldn't really understand what it was doing. All I knew was it was really, really fast, and it looked amazing, and I decided to learn Z80 assembly and to see what I could do. So about 4 or 5 years ago I started to make the Memo's Quest game, and I took my inspiration for it from the Oliver twins, who had written about a game that they were developing called Excalibur, and it was an open world game that they were making, but unfortunately it never saw the light of day. But they were making this open world game, and I was always fascinated by games like Elite and games that used an open world concept to build a game, and I started to make this game, Memo's Quest, to see if I could do something similar. So I started to learn about programming and how assembly programming worked, and how to make it the most efficient code that you could. And whenever I got tired of programming that, sometimes I would take a break, and I began to think about Harrier Attack, because it was a really great game. I remember playing it when I was a child, and had many fond memories of it. And I knew that it was quite a small game, and I knew that it was quite slow, and I wondered, since I have now taught myself assembly language, would it be possible for me to actually reprogram it and improve it? So that's what I started to do with Harrier Attack. So I want to just explain a little bit about how I decompiled the code and what I did to produce Harrier Attack Reloaded. And of course, this is the Harrier Attack disk, and there's a basic loader just called Harrier, which you can load into basic and see the AmpSoft loader, and basically that told me exactly where the Harrier Attack code, the main code, was loaded into, and also where the start of the code was at 8111 is the start of the Harrier Attack code. So my first goal was really to be able to decompile the code into WinApe and get it into a format that was readable and that I could compile it again directly from the WinApe memory and run it without having to use the Harrier Attack disk. So that's what I did, and you can just go into pause and you'll see the WinApe debugger, and what I did was I just selected the code for Harrier Attack, where it starts, and all I did was select the area of memory where Harrier Attack was loaded into, and then right click and you can disassemble. Now what that does is that disassembles the code into operating instructions, and as some of the code is graphics and some is sound and some is variables, you have to differentiate between that part of the code and functions. So once the code was disassembled into WinApe's memory, I found each operating code that was like a return or a jump instruction and made a line break so that I divided the code into functions, various functions. Of course I didn't know what any of them did yet, but I separated the code into functions, and because I had been learning assembly language for a few years, I knew what looked like real code and I knew what looked like sprite code or sound code or something else. So once I worked out what were real functions, anything else I knew must be data. So whenever you're disassembling in WinApe, then you can just the selected code in the debugger, you just click mark as data, or you can change it back, clear data area, and that just tells WinApe whenever you're disassembling the code that it's data, that it doesn't display it as operating codes, it just displays it as bytes, and so that was useful. So about 2022 is whenever I had the code, that the source code for Harrier Attack that was disassembled and was compiling correctly and running correctly in WinApe without the use of the disk file. And whenever I looked at the main code for Harrier Attack, I saw that it was, whenever the screen was being scrolled, it was doing a byte by byte copy across the entire screen, and I thought I'll try to speed that up. So I did successfully speed it up a little bit by using various tricks to removing loops and things like that in order to speed up the scroll, which was interesting. And this was my goal, really. My initial goal for looking at Harrier Attack was to try and see what I could do and try and improve it a little bit. I wasn't really wanting to do a whole project on it at that stage, but I managed to speed it up a little bit, and I realised it could be speeded up a lot more, because the Amstrad has what is called CRTC scrolling, which is like a hardware scroll that games sometimes use to do scrolls really fast. And as Harrier Attack was just scrolling 8x8 pixels at a time, it would be possible to replace the byte by byte scroll with a CRTC scroll fairly simply, and that worked out quite well. Although I found that whenever the CRTC scroll was happening, the entire screen was scrolling, so the flight instruments were scrolling, and whenever it got to the end of the screen, it would all scroll up a line. So it was corrupting the graphics, which was a bit of a problem that I had to overcome. But I found that by using the Amstrad Plus features, by splitting the screen, we could actually stop the flight instruments scrolling up the screen with the rest of the game graphics. And so that's when I thought, well, why don't I create an Amstrad Plus version of Harrier Attack? And so that's what I did. And we managed to get the scroll working and the flight instruments stationary, and then I thought about also seeing if I could improve the sprites. Of course, the sprites in Harrier Attack are all just black because the palette was limited in the original chipset, and they were quite flickery, and that was because the whole screen was being scrolled byte by byte, and then they were being redrawn again on top of that. So that's why the sprite flickers quite a lot in the original game. Of course, the hardware sprites on the Amstrad Plus are different because the hardware sprites have their own colour palette, 16 colours, and they are also separate from the main memory, so they don't flicker. So that was quite useful. And I looked at the original graphics, the original sprites, and I worked out from the game code the table of sprites, all the sprites that were in the existing game, and I took the original sprite and converted it into GIMP, which is graphics software on Linux, and I decided to try and design a new Harrier sprite. And eventually I designed a new enemy plane sprite and also a new carrier sprites, and joined them all together so that the game would look much better. And another thing you have to do whenever you're disassembling the original code is, because I'm working with a cartridge, and because the cartridge has no firmware, no Amstrad locomotive software in it to use for the various functions, I have to develop my own routines for the game. And there was 4 main functions that Harrier Attack uses in the firmware. And of course the main one is the characters. It uses the standard font in the Locomotive Basic, and that's why a lot of people think that Harrier Attack is made in Basic, because of the sprite size, which are all 8x8 characters, and also because of the original, it uses the original font of the Amstrad operating system. So I thought to myself, why don't I take the font that I made when I was a child, and which I still had on hardware on the hard drive, and use that instead as the game code in the game code. So I took the font and I printed it all to the screen, and then I made an assembler routine which ripped it from the screen and saved it into tiles which I could use to draw text on the screen whenever we have no firmware available. So that was the first obstacle. The second obstacle was the keyboard routine, because Harrier Attack uses the keyboard scanning routine in BASIC in order to control the plane. Now, I had already done some keyboard routines in my game Memo's Quest, so I thought that I will do that. I will just import it from Memo into Harrier Attack and see if I can get it to work. And it did work, but it was quite slow, because what I was doing was I was scanning the keyboard every time in the function that we want to check for a plane direction or a missile fire or something like that. So I was scanning the keyboard far too frequently than what needed to be done, so it was slowing the whole game down. And I had a long thought about that. I hadn't really looked at anybody else's code to see what they did, but eventually I worked out what to do. Another function that Harrier Attack uses is the timer, and of course in order to replicate that function we need to use interrupts, and interrupts in the Z80 calls an interrupt every 300th of a second, and it takes 6 of those to make up to draw the screen. So what BASIC does is every 6 of interrupts it increments a variable, actually two bytes, which makes a timer device that different games use, that the sound uses to function correctly. So in Harrier Attack Reloaded I had to work out how the timer function worked in BASIC and replicate it, which I did successfully. Eventually worked out how to do that. And so now we had a timer. I was able to put the keyboard scanning routine into an interrupt, so that every 50th of a second the entire keyboard is scanned and the results are written to a buffer. And then all we have to do is whenever you want to detect a key press in a function, all we do is look at the buffer and see has something been pressed. And of course that makes the game very, very fast, because we're not scanning the keyboard too frequently. And because we had interrupts, now we have the timer with the keyboard scanner, and we were able to create a function to redefine the keys as well. Now that was a big problem for Harrier Attack, because you couldn't redefine the keys. You could either choose keys or joystick, but you couldn't redefine them. And if you wanted to play them on the GX4000, it made it a little difficult. So after a bit of trial and error, I found the best way to create a function to redefine the keys was to use self-modifying code. And basically what that does is it detects a key press, and whenever a key is pressed, it returns a line and a bit number of the key that has been pressed into the keyboard buffer. And I found that if I detect a key press and work out what line and bit number it corresponds to, then if I self-modify the function to test for the up key or the down key, then I can write that line and bit number directly into the function, so that the game isn't having to check each time you press a key which key the user has defined for their up key or their down key. So that's how the redefine keys function works. And then because we had interrupts going, we could do a lot of other things as well. We got the sound working. Initially I imported the sound effect functions I had from Memo's Quest into Harrier Attack, and it worked a little bit, but it wasn't great, because the Z80, the AY chip, sorry, has very limited functions for sound. Basically, if you tell it to make a sound, it will keep making it until you tell it to stop. And it has sound envelopes as well, but they're fairly basic, and if you use a sound envelope, you can't control the volume of the effect. So what I needed to do was to make a function that basically ran every 50th of a second and check the sound buffer and see, do we need to modify the sound, do we need to modify the volume, do we need to silence the channel, and so on. So eventually I worked out a system whereby I could do all that. I could do sound fades, I could do changes in tone, I could do noise and different things to make imitate the original Harrier Attack sounds. And so eventually I got the ship sound at the start working, and the missiles and the bombs, and it was all working quite well. Another thing we could do in the interrupts, which a lot of programmers do, is to change the palette. And of course the Amstrad colour palette is fairly limited, which gives the machine a lot of character, but it makes the game fairly dull whenever you're just looking at 3 or 4 colours. And the original Harrier Attack was in mode 1, so the colour palette was fairly limited. So I decided, why don't I change the palette in the interrupts to make the flight panel flight panel colours different from the main game, and to give the sky a bit of a gradient, and to make the game menu also more colourful. So that's what I did, and the colour palette change makes the game a lot more colourful, and we're also able to use that to change the theme of the colours, like change from day into dusk, into nighttime, and into dawn, and back into daytime as the game progresses. So it makes the game a lot more interesting to look at. So when I first started working on Harrier Attack, I was mainly using WinApe's built-in assembler, but as I started to work on the cartridges, I found that it was getting a little cumbersome to compile the code and then compile the cartridge in the command line. So I decided to try and download a Z80 assembler program. The one I use is RASM, R-A-S-M. So because I'm no longer using WinApe's built-in assembler, I have started to use Notepad++ in order to program the code, and you'll see my development environment there on the left. There's Harrier Attack Reloaded, and these are the different files that we have here, and this is the main game code. With my modifications to it, and you'll see down the left here there's additional files. There's boot, which is the code to actually load the game code on the cartridge into memory, to set up the CRTC, to set up the color palette, and then jump into the code. And then there's the loader, which is for the disc, and then there's the loader cassette, which is the loader for the tape, and it just does the same thing more or less, only slightly more complicated, because the loader has to use basic firmware in order to load the game. So you have to juggle the code around a bit in order to get it into the memory before finally ditching the code, the Amstrad operating system completely, and allowing the code to take over. And then there's the Harrier screen, which I used conv image CPC to convert a JPEG of the Harrier and convert it into a format that would work, that would run on the Amstrad Plus. Then there's my Amstrad font, plus the extra code that I used. Whenever I was a child, I remember typing in a program that made multicoloured writing on the screen using some machine code, and I was amazed at this. And that's what I decided to use in Harrier Attack Reloaded as well. And although the font is all the one colour, the function that writes the tiles to the screen modifies the bits differently depending on which line it is writing to the screen. So like the top 3 pixel rows are light blue, then the middle 3 are medium blue, and then the end 2 are dark blue. And all the code does is whenever it's writing to the byte to the screen, it shifts the bits into the appropriate position in order to change the pen number of the graphic. And so that's how we get the multicolored text. I could have done it manually by recoloring each of the tiles in the graphics, but I thought it was simpler just to make a function that does it as it's written to the screen. So that contains my code for writing the graphics to the screen mostly, and also the Harrier Attack sprites, which I used the function to work out which sprite was which at the start. And then my sound effect code, which is, that's all my sound effect code, and then the code to tell the AY chip what to do as well. And then my batch Linux bash file, which actually assembles the cartridge or the disc or the cassette. So my bash file uses a couple of commands in order to create the boot code. First of all, we're using RASM to assemble the individual files into Z80 binary files, and then that's in this section here. And then once we have the binary files, what we do is this program here, ROM inject, it inserts them into a single ROM file, and this ROM file is what is burned onto the cartridge, onto the EPROM in this cartridge, which I'll show you in a minute. And then once we have this ROM file, then the build CPR command actually converts the ROM file into a file that the emulators can understand, WinApe and other various emulators. So that's basically what my bash file does. And in the code, in the main source, there are tags which I change depending on whether I want to compile a cartridge, or whether I want to compile a disk file or cassette file. This is the other bash file here, and basically what this does is this takes the binary files and converts it into a CDT file, which is like a file that emulates a tape, an audio cassette on an emulator. I use the program toCDT to do that. Now this creates two different versions of the CDT. There is a turbo one, which is like a high baud rate, and it loads the game really fast on the emulators, and it's quite high pitched. But I found that whenever I played that on my actual Amstrad 464, it didn't load, it didn't detect the game at all whenever I press play. So I found that I have to record a normal baud rate, which is a lot slower, but it actually works whenever you're using a physical tape and real Amstrad. So that creates a CDT file really quickly, and after that we then can convert the CDT file using a different program into a WAV file, and we can record that WAV file through a hi-fi system onto a cassette tape in order to load on a real Amstrad. So that's basically how we compile the game from the source code, and it looks fairly complicated, but it's not really. It does it very fast, which is good. So if there's a bug in a game I'm trying to fix, I can just run that bash file, and the entire game is compiled in under a second. Now this device here is an EPROM burner, and I got this off Amazon, I think, a couple of years ago, and it's called an X-Gecko Pro USB, and it's model T48 by Haiku Zingong Electronics. I think it's about 60 or 70 pounds, and it's used to burn the ROM file onto the cartridge that I showed you before. Now there is an adapter here that my friend Dan has made for burning the Amstrad cartridges, and it plugs into the EPROM burner and allows me to plug in a cartridge on top of it. And Dan, his username is Iverlot on eBay, so if you're wanting to get something like that, or if you're wanting cartridges burned, if you look up Iverlot, he will be able to do that for you, and he's done a lot for me, so I'm very grateful for that. He's been a great help to me. So you have to make sure it's Dan's written here, insert with front facing this way or you will break it. So you need to be very careful which way you plug that in to plug in the cartridge as well as plug in to the EPROM burner, and then that locks it in place, that wee lever. So it plugs into the USB, and the software I downloaded to burn it from some sort of Chinese website, and I'll show you that now. So I have VirtualBox here and a Windows XP installation on it, which I will launch, and hopefully it will work okay on this system. So this is Windows XP, and this is the software that I use to burn the EPROM X-Gecko Pro. I'll just double click on that, and then it asks you to select your model number, and my one's T48, and click OK. So I'll show you how it reads from the cartridge, so I'll just unplug this in a second. Plug in the cartridge. This is one I burned earlier, and I put the label on it this morning. So you see the front is where the arrows are. Now this cartridge is one that Iverlot Dan made for me, and it's very good quality, and it's 3D printed case, so it's nice. It feels really nice. It feels quite sort of chalky, which is a nice sort of feel to it, and of course it's white, which matches the Amstrad. All I do is plug that in on top of Dan's adapter, and just go to devices in VirtualBox and make sure the XGECU is selected so that I can read from it. You'll see it comes up programmer connected, and what I will do is I will click read and read again, and it's working okay. So it's reading what's on the EPROM, and click back, and you'll see there my game code for Harrier Attack Reloaded. This is what's on that ROM. And the select IC is very important because you need to match basically the software needs to know how to program your chip. So I opened one of these cartridges and I looked at the chip inside and I found this number on it, SST39SF040. So I had to type that number in to search for it and selected the first one on the list, and whenever I did that I was able to read from the cartridge and able to burn it correctly. Now what I do to burn the file to the cartridge is click load and then select my file, and then select the ROM file, click open, and then just click OK. And then there's a button here called program. This is actually Memo's quest here that I had done before on another cartridge. So you click program and basically click program on that, and I'll not do it this time, but once you click program it will burn the ROM file to the cartridge within about 5 seconds, and then that's your cartridge programmed with the game on it. So it's fairly quick to do, and it's once you know how everything works, it's not too difficult. But it's handy having Windows XP there for that purpose. So the actual cartridge cases, I got these from a place in America. Unfortunately there wasn't any local in the UK, but it's from a place called customgamecases.com, and I had to pay a bit of postage and customs to get them over here, so it wasn't as cheap as I'd hoped, but they're good quality and it's fairly simple to get a cover put in them. I designed the cover in GIMP again and got them printed by a company called instantprint.co.uk, and I made sure all the measurements were right. Unfortunately I got the spine slightly misaligned, but everything else is more or less as it should be. So I got those to put into the cases, and then I also, by the same company, got manuals produced. Now this is A6 in size, so it fits nicely inside the case, and there's about 10 pages of information about the game. I really wanted to put a little tribute to the original programmers of the game, Robert White, who was the founder and director of Durell Software. He was the inspiration behind the original Harrier Attack game, but he got another man called Mike Richardson to help him program it, and also another man called Ron Jeffs. So I contacted Robert White to tell him I was doing all of this, and hoped that he would have given me like a little paragraph or two just to put in as a tribute to him. Unfortunately he said that he felt that he was too old for all of this now, and but I got some tributes put in just from information I found on the internet about the programming of Harrier Attack, and I put a little bit about myself in, how that I came to work on it as well in the manual. And just at the start, I took the original introductory mission brief from the audio cassette, and I put it into AI and rewrote it so it's more dramatic, and also took the paper that I had from my Amstrad years ago and scanned it so it looks like it's crumpled, and also put like tractor feed holes, because I used to have an Amstrad DMP 3000 printer, and it was really great, you know, to have. It brought back lots of memories, all the noise it made as it went across the page, so that's why I put the wee dots down the side, so it's like tractor feed paper to bring back memories of the Amstrad. And then some pictures as well, photographs of Robert and photographs of the original artwork that he was working on to design the game, and of course my own sprites from the Plus version, and then a little bit about Nemo's Quest at the end just to fill up the space. So that's the manual that it comes with. So that's a little bit about Harrier Attack Reloaded and just how I came to develop it.